What does it actually mean to say a surface has one side? In everyday life, a side is about thickness. You paint the top of a sheet red and the bottom blue. But in mathematics, surfaces have zero thickness, so that idea breaks. We need a definition that works without paint. Mathematically, a surface in space is two-sided if you can choose a normal direction at every point, a tiny arrow sticking straight out of the surface, in a way that changes continuously as you move. If you can do that everywhere, then one direction is the plus side and the opposite is the minus side. A cylinder works like this. You can always point the normal outward, and nothing ever forces it to flip. A surface is one-sided if this is impossible. Locally, every small patch still looks like a piece of paper. The problem only shows up when you move around certain loops. This failure is called non-orientability. Now look at how the Mobius strip is built. Start with a rectangle. To make a cylinder, you glue the left edge to the right edge so that each point lines up directly. Formally, the point 0, t is identified with 1, t. Nothing flips. For a Mobius strip, the identification is different. 0, t is glued to 1, t. That minus sign is the entire story. It represents a half twist, and it reverses orientation. Here is the key argument. Pick a point on the Mobius strip and choose a normal direction there. Now move continuously along the strip, staying on the surface, and go once around the central loop. You are forced to keep the normal changing continuously. When you return to the starting point, the geometry forces the normal to point in the opposite direction. Symbolically, the normal vector n turns into minus n. That is a contradiction. At a single point, a unit normal cannot be both n and minus n at the same time, so there is no way to choose a continuous normal direction everywhere. That is exactly what it means to be one-sided. This also explains the familiar marker experiment. If you draw a line without lifting your pen, the path passes through what feel like both sides without crossing an edge. That is the physical version of the same topological fact. There is no consistent front and back. Another piece of evidence comes from the boundary. A cylinder has two separate boundary circles. A Mobius strip has only one. When the rectangle's edges are glued with a flip, the top and bottom edges connect into a single loop. The same twist that kills orientation also merges the boundaries. So the conclusion is precise. A Mobius strip is one-sided because its edge identification reverses orientation. That reversal makes the surface non-orientable, which means no global normal vector exists, and without a consistent normal, the idea of two sides collapses into one.